If possible, which means maybe it's not, but if possible, evaluate the limit as x tends to infinity of 4 to the x plus 3 to the x over 6 to the x minus 5 to the x. Okay. So, the usual thing to do is sort of try to naively plug in. Now, you can't actually plug in infinity. 4 to the infinity makes no mathematical sense. But you can sort of reason your way through and say, look, as x gets really big, 4 to the x gets really big. So you get sort of an infinite expression here, plus another infinity. You get another infinity minus another infinity. And the whole expression looks a little odd. Okay? Infinity plus infinity, for the most part, will settle down to an infinity. But infinity minus infinity, this is an indeterminate form. Even if you resolve it, you might actually get an infinity over infinity. I think you do this time, which itself is another indeterminate form. So, yikes, there's a lot going on for this, I would say, rather simple-looking expression. So, okay. But we tried, and we got a sense of, all right, this requires some more advanced techniques. We can't just plug in and call it a day. Of course, you can never plug in with infinity and call it a day, but it's the spirit that counts. Okay, but what I noticed there was we've got a lot of infinities. Okay, all of these are exponentials. They're all getting really, really big. Okay, getting really big over time. But if you look, they all each have different bases. Okay, and so different bases with exponentials can mean a world of difference in the long run, on the extreme side of the graph. Yeah, if you look at it sort of locally, 5 to the x and 6 to the x, I mean, the one is getting a little bit bigger than the other, but if you zoom out, 5 to the x basically looks like it's standing still compared to 6 to the x, which will shoot up like crazy if you're starting to plug in things like x equals 1,000,000, x equals 1,000,000,000,000, okay? The 5 to the x, and for that matter, the 3 to the x on top, won't really matter. Okay? What we have here with these pluses and minuses is we have sums of terms in the top and the bottom, but one of these terms is growing bigger than the others. One of these is more dominant than the others. Okay? When it comes to exponentials, the bigger the base, okay, if you're doing a limit, again, as x tends to infinity, as we've said a few times, as x tends to infinity and you're talking about bases bigger than 1, the bigger the base means you've got a much, much bigger function. Okay. So, 6 to the x is crazy big compared to 5 to the x in the long run, which means the bottom here is basically just 6 to the x minus this tiny little annoying fly that we can ignore. And while we're talking about it, 5 to the x, because 5 is bigger than 4, 5 to the x is much, much bigger than 4 to the x. We're not going to need that fact, but this is also true. It's much, much big, and 4 to the x much, much bigger than 3 to the x. So what we can do is we can say, look here, I've got a dominant term on top, we've got another dominant term. As far as the limit is concerned, 3 to the x, 5 to the x, who even are those? So what we can do is we can factor out, we'll rewrite our limits slightly. We can factor out 4 to the x on top. So take out a factor 4 to the x from 4 to the x, you get 1. You'll get 3 to the x over 4 to the x. Or you could write that as 3/4 to the x. On the bottom, we can factor out a 6 to the x. And you'll get 1 plus 5 to the x over 6 to the x, or you can say 5/6 to the x. Okay. But now look at these. Because 3 is less than 4, the base here is between 0 and 1. Well, as x gets really, really big, this part goes to 0. Right? Exponentials where your base is between 0 and 1 tend to 0 as you head to the really far right. Same thing down here. So we can just ignore this. This guy goes to 0. This guy goes to 0. So what we really have is this limit is the same as 4 to the x times 1 plus 0, which is just 4 to the x. Okay, these limits are the same. Once you factor out the dominant terms in sort of a ratio or a division like this, the limit is going to behave exactly the same as the limit of the dominant terms ratio. So this is really just 4 to the x over 6 to the x in the long run, which we can do sort of the same thing. We can factor it and say, well, it's 4 over 6, or rather 2 over 3 to the x. And again, 2/3 is between 0 and 1. So this limit is going to be 0. If the 6 to the x was on top, we'd have a limit of 3 over 2 to the x, and that would go to infinity, which means that the whole thing would go to infinity. But because of the way it worked, the dominant term on the top here, is smaller than the dominant term here. Well, that can happen. So the whole limit, in the end, goes to 0. There we go.